Hello everyone, we are group number 3 and we will be presenting on testing of isolators and busbars. So first and foremost, let's understand what is isolators. Isolator, it is a mechanical switches used to disconnect a circuit from its circuit element from the circuit. Through this we can ensure a complete electrical isolation when the isolator is open. So, and another point, it also prevents accidental energization of circuits when the work is on. This isolator is usually used alongside the circuit breakers in order for a safe working environment. Now, there are various types of isolators. First one is a single break isolator, and the second one is vertical break isolator. This one is a vertical break isolator, and this one is a double break horizontal isolator, and lastly the pantograph isolator. Now we are not much concerned about these types of isolator. We'll directly move on to testing later. But before that, we also need to understand what busbar is. Busbar, it is a thick strips of or bars of copper or aluminum that conduct electricity with a switchboard, distribution board, or substation. Now, this busbar is usually a copper bar which connect multiple circuits in a common circuit point. Now, this helps in distributing electricity power efficiently to various circuits. Now, this busbar is usually metal, therefore the resistance is low for that, which means when the resistance is low, the current carrying capacity is more. Now, usually in a panel where we require multiple wires, but in case of busbar, we can just simply replace this multiple wire with a single copper bar. Now, these are the various types of busbar. First one, the single busbar system, where we use only a single bar. You can see here RYB, only single. And in case of double busbar system, you can see a double copper busbar are being used. And in this one is a ring main arrangement where the arrangement of the busbar is done in a ring configuration. Likewise, there is also a mesh arrangement of a busbar system. Now, coming to routine test, this routine test is conducted on every unit before dispatch. Now, this includes a visual inspection of the busbar and isolators, and also a mechanical operation test. It also includes tests where there is a measurement of insulation resistance value and also a contact resistance test. Now, there's moving on to type test. It is usually performed on a prototype. There is isolator and busbar. Now, this includes lightning impulse test, power frequency voltage withstand test, temperature rise test, short time current test. Now, coming into functionality test, this test ensures that the device performs as expected. Now, this test includes a manual and motorized operation, interlock functioning, arc switch operation, simulated fault conditions. Now, coming on to factory acceptance test, this test is usually witnessed by client representatives. The sole purpose of the test is to verify the technical parameters of technical specification, verify the technical specifications, and it is also to identify issues before the installation of the site. This typically includes electrical performance, dimensional check, control circuitry verification. Now, lastly, regular maintenance test. This is scheduled test during the life cycle of the equipment. There are isolator and busbars. Now, this is to mainly continue to check the continued reliability and detect aging and failure. This includes cleaning and lubrication, contact resistance, insulation checks, mechanical integrity. Now, this is the main part of our case study. First one, I'll be talking about Busbar testing, which include first one, the partial discharge test. This partial discharge test is it is a test where partial discharge is measured in coulombs. This is also known as arcing, and this is done between the conductor and the insulator that is applied to the surface of the busbar. Now, arcing usually, partial discharge, which means arcing, this usually occurs between the insulator and the conductor, and when there are pits on the surface of the busbar. This arcing causes erosion of the insulation, leading to insufficient power transfer and, at the worst case, total failure of the insulation system. Now, this is the arcing that you can see here between the busbar and the insulator. Now, coming on to the second test, it is a hypo test. It involves measuring the distance between busbar and the ground. It helps in ensuring continued operation and prevent unexpected breakdowns of the insulator. This test is conducted at the voltage of almost 1000 volts. Now, this is the rough picture that we got for hypo test. Now, lastly, for busbar testing, it is the ampacity test, where it directly measures the heat rise using thermocouples and thermal imaging devices by giving specific amperage through the test specimen. Usually for this, ampacity table is being used, but for parts with more geometrically complex, this test is preferred in order to avoid introduction of variables that will skew performance from basic estimations. This is the overview of the ampacity testing. This is the thermal imaging device that is being used to do the test. Now, coming on to isolator testing. First one, it is a support isolator IR test. This test is directly done on the porcelain part of the insulator. And for this, we use 5 kV motorized measure, and through this, the IR value measured should be greater than 10,000 mega ohms to prove that the insulation is good for the isolator. Now, you can see here that measure is used here. One terminal is being connected to the directly porcelain and one to the metal surface. Likewise, secondly, we have IR test of motor. This test is also done using measure, but we use 500 volts motorized measure, and the expected value should be greater than 100 mega ohms to prove the best, to prove its quality of insulation. Now, lastly, IR test for context. This test here we also use measure, but the measure use is rating of the measure use is 5 kV motorized measure, and the value should be greater than 10,000 mega ohms to prove good insulation. Here, both the contacts should be measured for both the isolator contacts. And this is the circuit diagram of how the test is being done. You can see that one terminal of measure is being connected to the one point of contact, and the other point of terminal of the measure is being connected to the other part of the isolator. Now, we are done with our presentation, and this is the results. Thank you.